Alright folks, welcome back. We are going to be talking about pH and pOH. This is our third podcast with acids and bases. You're going to need your calculator today. Make sure you have your calculator out. So pause the video, get your calculator, get ready to take some notes. We're going to work through this. Alright, this is just a reminder. We have 6 strong acids that we care about. The first 3, hydrochloric acid, nitric acid, and sulfuric acid. These are very common. Remember that they completely dissociate, and that's why they're called strong acids. And hydrobromic acid, hydroiodic acid, and perchloric acid are also strong electrolytes. They're strong acids, but they are not anywhere near as common. Right. Just again a reminder, they readily transfer hydrogen ions to water and they form hydronium ions. So sometimes we're going to write H+, and sometimes we're going to write H3O positive. Either way, it means the same thing. It doesn't matter because H pluses are just lone electrons, so they tend to go and be attracted to water to form H3O. We talked about that last time. Okay, so we will sometimes just write that as H+, we'll sometimes write it as HCl, depending upon whether we include the water or not. Right, bases, remember you have a couple of strong bases, sodium hydroxide, potassium hydroxide. The other 3, using the group 1A metals or the alkali metals, are also strong, but they're very uncommon. So we tend to focus on sodium hydroxide and potassium hydroxide. We do have a couple of substances that are amphoteric. You should write these down. Specifically, you should write down the definition for amphoteric, which is a substance that can act as an acid or a base. And the most common one is water, but we also have amino acids that can act either way. But really our focus, because we're chemists, our focus is going to be on water. If you're a biologist, you're going to focus on the amino acid part. Okay, it can act as an acid or a base, meaning it can act as a proton acceptor, which is when it becomes, when water acts as a proton acceptor to become H3O positive, or it can act as a proton donor where it gives away the proton to become an OH minus, or we give the proton to something else. Alright, now water actually naturally dissociates. So as I look at water down here, water can actually dissociate into H plus and OH minus. So these aren't all water molecules you see down here, right? Sometimes some of the water will dissociate. Alright, and so this is a concentration. Right, so that's what these little square brackets mean. It means concentration in molarity. So you get 0.000001 moles of H plus ions in a mole of water. Similarly, you get 0.000001 moles of OH minus ions in water. Right, so that's what these things mean. They mean concentration of water. So it isn't all water molecules. It actually breaks apart into some naturally occurring hydrogen and OH ions. But you'll notice the number of hydrogen ions and the number of OH ions is exactly the same. They're going to be balanced. Why? Because they came from water. So of course they're balanced. Okay, that should make sense. So we're talking about the molarity of hydrogen ions and the molarity of OH ions. Now when they're balanced, you have something that is neutral. But when you get them unbalanced, it's no longer neutral. Now, if you notice that these two numbers, when you multiply them together, gives you 1 times 10 to the minus 14th. And that's going to be true in water, because that's going to be our concentration of H plus and OH minus ions. So if our H plus goes up, our OH goes down. So if our H plus ion went up to 1 times 10 to the minus 3, then our OH ions would go down to 1 times 10 to the minus 11th. Right? Because, again, you multiply the two of them together, you have to get 1 times 10 to the minus 14th. Now, we do have a pH scale, and a pH scale is based on logarithms. Now, if you're in Algebra 2, you should have seen logarithms by now. If you're not in Algebra 2, then you don't have a clue what logarithms are, but essentially what they are is they're something that is based on an exponential scale of base 10. If you need more explanation, please come see one of us in class. We'll help you out. All right. Bottom line is, you have a pH scale that goes from 1 to 14. And this has to do with the concentration of hydrogen and OH ions. We'll talk about that in a minute. If we have something that's below 7, like 2 or 3 or 4, then those things are going to be acidic. But if we have something that's above 7, then we have something that's going to be basic. All right? So it all depends on what the pH scales are, and the extremes are bad. So for example, if we have something that's a 0 or a 1, that's very acidic, and if we have something that is 13 or 14, that is very basic. Right? And those can hurt you. Okay? Now, we just looked at this. These are concentrations, but what is pH? Well, if you have 1 times 10 to some number, when we look at this, this is 10 to the minus 7th, that is going to have a pH of 7. And if our concentration of OH, again, that number right there is going to have a pOH of 7. So without doing any major math here, if I look at the exponent and make it negative, in other words, convert it from negative to positive, that's going to be my pH if I'm measuring my hydrogen concentration, or my pOH if I'm measuring the OH concentration. So remember we talked about if H plus is 1 times 10 to the minus 3, well that would mean my pH would be 3. And if I remember, pH of 3 means it's very acidic. Alright, so my pOH would then be 11. Now, you can't be confused, because if you see a pOH of 11, you don't say, well, that's basic. No, that's not true. A pH of 11 would be basic. Now, how do I know how to relate my pH and my pOHs? Well, my pH plus pOH is equal to 14. Gee, that looks a lot like what we just saw, where our concentration of H times our concentration of OH equals 1 times 10 to the minus 14th. So that 14 is still there. Right? So this is another one of those equations that can help you. If you know your pH, it's real easy to figure out your pOH. In other words, you're talking about concentration of hydrogen ions and concentration of OH minus ions. Alright, so when we talk about a pH of 7, because water is naturally dissociating, you have a pH of 7 because that number right there forces you to have a pH of 7. And your pOH, because 7 plus 7 is 14, your pOH is also going to be 7. Alright. So, remember, in your pH range, the more acidic you have, the lower your number is. And down here, the higher your number is for more basic. So if I'm looking at my pOH, and my pH happens to be 4, right? Then my pOH is going to be, what do you think? Sure, it's going to be 10, because 10 plus 4 makes 14, right? So if your pH is 4, your pOH is 10. Similarly, if I'm down here, if my pH is 10, then my pOH would be equal to 4. So you should be able to figure those out by looking at your pH range. And we talked about a lot of things that are over here, so take a moment, pause the video, and look at what these things are. All right, we've talked about some of those and whether they are acidic or basic. Alright, again, pause the video, write these down. You need to have these equations. They need to be usable to you. Alright, we're going to talk about exactly how to fit these together. But these first two are two we've already talked about. And the rest of them, you have to be able to do logs for the first two, and you have to be able to take 10 and raise it to a power. Alright, you got them all? Hope so. We're going to be using them. What I do want to do is I want to relate these equations to one another. Right? So to go between pH and pOH, what I have to do, this is where the pH plus pOH is equal to 14. And this one over here, going between these two, is where you know that the concentration of hydrogen ions times your concentration of OH minus ions is going to be 1 times 10 to the minus 14th. Right, now these guys up here, this is where you've got some serious math to do, going in both directions. Right? So if I'm going to the right, my pH is equal to the negative log of the concentration of H plus ions. Now similarly, that will allow me to go to the right, because I'm going to pH. If I want to go the other way, if I want to go to the concentration of H ions, this is going to be the concentration of H ions is equal to 10 to the negative pH, whatever that number is. And I say, well, wait a minute, can't I just do the 1s and 2s just like we did on the previous pages? Well, that's fine, but what happens if your pH is 1.2? Right? I can do a pH of 1 in my head. I can't do a pH of 1.2 in my head. That's where I need my calculator. Right? Similarly, if I want to go down here, if I'm trying to get to pOH, my pOH is going to be equal to the negative log of my OH concentration. And the concentration of my OH, negative ion, is going to be 10 raised to the negative pOH. So it's very similar to what you have above. You still have negative logs and you still have 10 to a negative power, but you need to be able to do those, right? Because here we have a chart where you should be able to go between concentrations and pHs and pOHs, right? So I'll do one for you, right? Just so that you can figure out how to make these things happen, right? Going between these two and going between these two is very easy, right? Because here all I have to do is add them up to get to 14, and here all I have to do is multiply them to get to 10 to the minus 1 times 10 to the minus 14. So if I just do this one, this is going to be 1 times 10 to the minus 14 divided by 2.3 times 10 to the minus 3. Now, when you plug that into your calculator, be very, very careful. Use the second EE key. And remember, when you're putting in this minus sign, you're not doing the one where you're subtracting one from another. You're using the special key, which means negative. Right? So, when you do that, you're going to come up with 4.4 times 10 to the minus 12th. Right? So, that's the way you come up with that one. Now, how do I come up with my pH or my pOH? Well, my pH, if you remember your pH, let's go and look this back up. Your pH is equal to, well, we just did this on the previous page. So your pH is equal to the negative log of your hydrogen concentration. So your pH is equal to the negative log of your hydrogen concentration. All right, so I have to plug that into my calculator. So I have to go and put in a negative sign, and I have to take the log function on my calculator, and then I have to put in my hydrogen concentration, which is 2.3 times 10 to the minus 3rd. Now just looking at this, my pH should be something close to minus 3. I'm sorry, to 3, because you get rid of the minus sign. So it should be something close to 3, and in fact, if you do this correctly, you'll come up with about 2.64 or 2.6 as your pH. So how do you come up with your pOH? Well, you can do the same thing here. You can do the negative log of this number, or you could just subtract 2.64 from 14, which is what I would prefer to do, and that's 11.36. Now, is it an acid or a base? Well, you've got a number that's 2 and you've got a number 11. Which do I look at? Well, to figure out if it's an acid or a base, you always look at the pH. Right? And just looking at the pH, that tells me that my number over here should be an acid. Because 2.6 is way less than 7. So that's going to be an acid. Alright, so what I'd like you to do is pause the video, see if you can do the next one. Alright, welcome back. Again, to figure this out, you work your way backwards. You know that the concentration of hydrogen times the concentration of OH gives you 1 times 10 to the minus 14th. So if I start with 1 times 10 to the minus 14th, and I divide by 4.8 times 10 to the minus 3rd, right, then my answer here is going to be 2.1 times 10 to the minus 12th. So let's pause for just a moment and think about this. Do I have more OHs or more H's here? Well, that can be complicated, and you might say, well, I've got more H's. Well, no, you don't. You have more OH's. Why is that? Well, remember that you're going to a negative exponent, so this is 0.0048 as a concentration, and this is 0.00000000000021. Well, this is a very, very small number. This is much bigger, so we have many more OH's than we have H's, so that tells me this should be a base, right? I mean, you should be able to figure that out. All right, let's go and calculate my pH's. It should be close to 12. My pH should be close to 12. My pOH should be close to 3. Right? So if I do this, and I use this formula where the pH is the negative log of H+, so I have the negative log of 2.1 times 10 to the minus 12th. Right? If I plug that in my calculator, right, the number that I come up with is about 5.0. Well, so what's my pOH? Well, my pOH then is going to have to be about 9.0. Now, I only had 2 sig figs in my problem, and that's why I'm coming up with I'm sorry. Let's try that again. I'm looking at the wrong line. Let's try that again. That's 11.7. And that's 2.3. My bad. All right, so do I have an acid or a base? Well, 11.7 is significantly bigger than 7, so I have a base. And these two numbers here, they add up to 14, which is what I expect them to. All right, how about the third one? Can you do that? I can do that one in my head. Can you do that one in your head? Pause the video, see if you can do it. Well, let's see. Here I've got 5, so that means what I have to have over here is 9.0, because 5 plus 9 gives me 14. Because it's 5, that's less than 7, so that means I have an acid. Okay. Now, what do I have over here? Well, remember, I don't even have to do the. I don't even have to work backwards. Now, if you were working backwards, then your concentration of H ions is equal to. Let's go back a page. Your concentration of H ions, if you're working backwards, is 10 to the minus pH. So that's going to be 10 to the minus pH. So that's going to be H. That's going to be 10 to the minus 5, right? So that is simply 1 times 10 to the minus 5. Well, that means this has to be 1 times 10 to the minus 9. Same reason, or you can say they multiply together to make 1 times 10 to the minus 14th. Either one. All right, so that one was really easy. All right, how about this last one? Well, the last one's going to be pretty close to neutral. It isn't neutral. It is going to be slightly acidic, but it's close to neutral. See if you can figure this out. All right, well, certainly I can get to my pH, which is 6.75. All right, so that is slightly acidic. Slightly acidic. Right? And when I work my numbers back over here, I'm not going to waste your time doing the whole thing, but it's 1.78 times 10 to the minus 7th and 5.62 times 10 to the minus 8th. All right, so that's it for those. Remember how to test pH? We can test pH using litmus paper, the blue paper and the red paper. We can use phenolphthalein as an indicator. Remember, it is either clear or it turns pink. And then we have universal indicator paper, which turns all sorts of colors, and universal indicator dye, which at neutral is green, and then turns different colors for red or purple, depending upon whether the other acids or bases. Right? And again, you'll see that in the next podcast. Right? That's it, folks. That's it for pHs. If you have questions, please see us in class. Please do the worksheet. Make sure you know how to do this stuff and that you can work these numbers quickly, because they'll be on a test.